Hi, I'm Amanda.
And I'm Franklin.
We're from Dr. Kishimoto's 271 class.
And we'll be presenting problem number 5 for our video project. And I'll be presenting the first half of the problem.
And I'll be doing the second.
So the first half of the problem asks us to determine the magnitude and direction of the electric field at point P. As seen on the diagram, we have an equilateral triangle with sides of 3 centimeters each. In order to approach this problem, we must first know the electric field equation founded by Robert Faraday. Before we start plugging in numbers into the equation, we must first take into account the units used in this equation. Looking at our diagram, we can see that the sides are 3 centimeters each, so we must convert those in order to plug them into our equation. Also, looking at the charges, we can see that they're nanocoulombs rather than coulombs, so again, we must convert them. Looking at this diagram, we're able to determine where the direction of the electric fields will be pointing. We know that negative electric fields pull towards a point, while a positive field will push towards a point. Because we know it's an equilateral triangle, we know that every vertex is 60 degrees. With this knowledge, we are able to split up the electric field vectors into x and y components. Looking at our negative 6 nanocoulomb source charge, we can see in the x direction that we plugged in our numbers. First, we have Faraday's constant, which is 8.99 times 10 to the 9th. And then for our charge, we took into account that it was given in nanocoulombs, so we converted it into coulombs by multiplying it by 10 to the negative 9th. Similarly, we converted the 3 centimeters into 0.03 meters. We take into account that we are going in the x direction, so we use cosine of 60. Component, we do exactly the same process, however, we use sine of 60. Positive 8 nanocoulomb source charge, we do exactly the same process. Last step in finding the electric field at point P, we must find the magnitude of the electric field. We find the magnitude by adding up our x components and our y components, and then squaring both, and then adding them, and then taking the square root. With this, we find the electric field's magnitude, which is 7.20 times 10 to the 4th newtons over coulombs. For our direction, we simply take the inverse tangent of our y components over our x components, and we find that it is 13.9 degrees above the x-axis. And that's the process for finding the electric field at point P.
I'm going to do the second half of the problem, which is the same setup as the first, except there is now a negative 4 nanocoulomb charge at point P, and we are asked to find the force instead of the electric field. Two equations that allow us to find force, but we are going to use the one on the right in this picture because we are dealing with two charges at once and not just a single charge. The picture can help you when you are doing this problem, and it is the same picture as the one we used in the electric field, except for our arrows point in the opposite directions because we are finding the force, and the force for a negative charge is in the opposite direction as the field. You can begin the problem by either finding the force from the negative 6 or the positive 8 charge, but we're going to begin with the negative 6. All you do is take your equation on the top right and plug in the values that you know. K is a constant, and then the top two are your charges. Ensure that you change the nanocoulombs to coulombs before plugging them in, and on the bottom is your distance between the two charges. Also ensure that you change the centimeters to meters. You then multiply by the cosine for the x direction and sine for the y direction. We now repeat the exact same steps that we did for the negative 6 nanocoulomb charge, but for the 8 nanocoulomb charge. As you can see between the two, the only difference is that you're going to exchange the 6 times 10 to the negative 9 coulombs for 8 times 10 to the negative 9 coulombs. Final steps is just to take the x components for each charge that you just calculated and add them together, and also add up the y components. To find the magnitude, you take the square root of the x components squared plus the y component squared. And to find the angle between them, you take the arctangent of y over x.